We're starting our unit on balancing equations, and we have already done some of this outline of what a chemical equation is. So I'm going to go through it pretty fast, but these are your notes. First of all, balance. Sometimes it's called a skeletal equation. I do have nitrogen, and I'm going to react with hydrogen. It's going to create ammonia, but it's not a balanced equation. Balanced equation is when I have the same number of atoms on both sides, and we use coefficients to balance, and that's what we're going to work on for a couple of days. So just to go over, remember our reactants are on the left, our products are on the right. This little arrow is the yield sign, so reactants yield products. Products come out the end. When you're done in a factory, the last thing that you have is products, and they come out the end. That's how you can remember it there at the end. These little numbers after a chemical symbol is a subscript, and these big numbers in front are the coefficients. This tells me how many atoms I have. This number tells me how many hydrogen gas molecules I have. So I have 3 hydrogen gas molecules. So one thing we haven't talked about is reactants. What happens is these bonds break, and then the chemicals rearrange and they form a new substance. So new bonds are formed. What you need to know is that it takes energy to break apart bonds. So if I take this magnet, it takes energy to break apart that magnet, and if I just let go, my bonds form, and that will give off energy, okay? And we'll talk about exothermic and endothermic on another day. And so let's go over why we are balancing this reaction. Well, first of all, if I have a container and I put in a bunch of reactants and I put a lid on it, when it's all done and rearranged, did anything jump out of my container? No. So we have to have the same amount of matter that we put in at the beginning and the end. And that's called conservation of mass or conservation of matter. Matter is not created nor destroyed. Okay, so what we're doing here is we're balancing atoms. Nitrogen has 2 atoms and they're touching because they're bonded. And why are there 2? Because that's one of your diatomics, and I have a video to remind you of that today. And then our hydrogen, we have 3 H2 molecules. So notice 1, 2, 3 hydrogen gases, but there's 2 atoms bonded for each hydrogen gas, so that's 6 atoms. And then that's a total of 8 atoms. Okay, and then over here we have ammonia. It rearranged and formed ammonia. 1, 2, 3, 4, 5, 6, 7, 8 atoms. Okay, I have 2 nitrogens and 3 hydrogens, but I have 2 of those molecules. So 8 atoms equal 8 atoms. They're certainly different and they're rearranged, and I have a completely new substance. But conservation of matter says I have to have whatever I started with at the end. Okay, so just so you can know, we are balancing atoms. Notice we have 4 compounds here, 3, 4, and only 2 compounds here. We're not balancing compounds. We're not balancing subscripts. We're balancing atoms. Okay, and the last thing I want to talk about is that you do not change subscripts in an equation. So here, I can't change that to a 4 or a 5 because the formula for ammonia is NH3. Okay, so if we look at water, water's H2O. If I change that subscript, it would change into hydrogen peroxide. They're not the same thing. So never, once you are talking about a compound, you can never change those subscripts because then you change the compound. And now we have 2 videos to go over in detail what balancing is and how we use these diatomics and how we write them correctly.